we go, guys. Okay, what is the first thing that we have to do? Find the LCD. Now, anytime you go to find the LCD, you're going to look at the smaller number and you're going to ask yourself, does 3, in this case, the 3, does the 3 go into the larger number, which is 9, evenly? Then that means 9 is the number we're going to use. We don't have to multiply. Like in the last example, we had to multiply. This one we don't, because 3 goes into 9 evenly. And then we have an X, so that is our LCD. Then you know the next thing I'm going to ask you is let's find those domain restrictions. You guys, your domain restrictions, you find them the same way we did in 8.1. You just set all the denominators equal to 0 that have a variable in it, okay? Not just all of them, just the ones that have variables. So we're going to set 3x equal to 0. That means x does not equal 0, because if I divide 0 divided by 3, I get 0. I'm going to set this x equal to 0. Well, that means it doesn't equal to 0. So my domain restriction is x can't equal 0. Okay, so we found our LCD. We found our domain restrictions. Now what we're going to do is we're going to multiply each term by the LCD. So 4 over 3x, that's our first term. We're going to multiply that by 9x. 7x, we're going to multiply that by 9x. And we're going to multiply 5/9 by 9x. Okay. 3x goes into 9x how many times? 3. And I have left over 3 times 4, because this 3 and then that 4. X goes into 9x how many times? 9, right? So we have 9 times 7. I got the 9 from the LCD. I got the 7 from the second term. Less than, well, 9 goes into 9. I'm left with x, so I have 5x. 3 times 4 is 12. 9 times 7 is 63, and that is less than 5x. 12 plus 63 is 75, which is less than 5x. I'm going to divide both sides by 5. And what is 75 divided by 5? So, we're saying, we're saying that 15 is less than x. We're going to draw a number line. We're going to put 0, and we're going to put 15. And we're going to do the same thing we did in the last example. We're going to pick a point that's less than 0, a point that's between 0 and 15, and a point that is larger than 15, okay? And we're going to decide what areas x can be. So it doesn't matter. What's a number less than 0 you want to test? -2. Let's test -2. So this means in the original equation, I'm going to do 4 divided by 3 times -2 plus 7 divided by -2, and it needs to be less than 5/9. Just a reminder, 5 divided by 9 is 0.5555. Okay, so we want something less than that. So we're going to do 4 divided by -6, because 3 times -2 is -6, plus 7 divided by -2, and the reason we put -2 there is because it's just plain x. And is that less than 0.55555? Is -4.16 less than 0.555? It is. You guys remember, that's negative money, and 0.55 is positive money. Okay, let's pick a number between 0 and 15. Any number between 0 and 15. 7? Let's do 7. So we're going to do 4 divided by 3 times 7, which is 21. So 4 divided by 21 plus 7 divided by 7, because we said x was going to be 7. And I get 1.19. Is that less than 0.55555 or greater than 0.55555? It's greater. So that means this area, this section right here, does not work. Now let's pick a number that's greater than 15. What do you want to test? What? I'm sorry, I didn't hear you. What's the number greater than 15 you want to test? Let's test 16. So we're going to do 4 divided by 3 times 16, which is 48. So we're going to do 4 divided by 48 plus 7 divided by 16. So 4 divided by 48 plus 7 divided by 16. And the reason we're using 16 is because someone picked it and we're putting it in for x. Is 0.52, whoops, sorry guys at home, and is 0.5208333333 less than 0.55555555555? It is. So that means that x is less than 0 or x can be greater than 15. What questions do you have? Again, you guys, once you get your answer, you need to test each section of the number line, and that's how you'll find out where x can be. So you guys, those two sections, you can use any of those sections to make it a true statement.